All right, I'm going to be defining, whoops, move my screen back. I'm going to be defining position in this video. If you haven't watched my video where I explain what displacement is, you're going to want to go ahead and watch that video because I use the term in order to define position. So an object's position is its displacement from a reference point. So and again, that word displacement, if you don't know what it means, you need to go watch the video on displacement. Because it does have a very specific meaning, right, in physics. This is a very important word. So it's an object's displacement from a reference point. What do I mean by a reference point? Well, I just mean a point, right? Any point in space, right? Any point anywhere. Usually in our class, our reference point is going to be 0. That's the easiest reference point to pick. So here I've just drawn a number line, and the reference point on the number line is the number from which our number line sort of starts, right? When you draw a number line, you draw arrows coming out, or you draw one arrow to the right, pointed into the right from 0, and you draw one arrow pointing to the left of 0. And what do you do? Well, you start counting, right? 1, 2, right? 3. We all have seen a number line. That was like elementary school, right? -1, -2. Maybe that was a little bit more like middle school by the time you made it to negative numbers. But we've all seen a number line. And here, right, this is my reference point. That's my 0. So let's get back to position. So in physics, we're going to use 0 as our reference point in most situations. What's kind of cool about the way I've defined position, right, is it doesn't have to just be a number line. I could draw 2 number lines. And if I draw 2 number lines perpendicular to each other like this, what do we usually call them? Well, we call them the x-axis and the y-axis. So now, right, what I've done is created a reference point, not just in one dimension on one number line, but in 2 dimensions on 2 number lines. And so now, and in this class, we'll mostly use 1 or 2-dimensional positions. So I'm going to go ahead and do a 2-dimensional position, which is the more difficult position. As you add dimensions, things tend to get a little bit more complicated, right? Because you're adding more numbers. And let me just put some numbers here: 2, 3, -1, -2. It is also important, right, for me to kind of write a couple numbers on each side of the y-axis as well, so you know which one is, which arrow is pointing in the positive direction and which arrow is pointing in the negative direction, right? Because remember, these negatives and these positives are actually telling us the direction, which is important for displacement. So let me get my eraser out, and I'm going to erase this. And I'm going to just put a position. So an object, like a box. No, let's not do a box. Let's do a person, right? So I'm going to draw a person. I'm going to draw them right. I still have an eraser set. I'm going to put the person right here. Okay. And if we were asking where this person's position is, right? I've told you it's its displacement from a reference point. Our reference point, right? For convenience, we're just going to use 0. And let's say, since I've drawn this person sort of big, like, say, where is this person's foot? Well, this person's, and we'll say his right foot. Where's their right foot? Well, it's just their displacement from the reference point. So if I drew that out, that would be about, let's say about 2. Oh, it's 2-ish. Okay, so uh, the object's position here is 2, 2, right? And you've seen this before in math, an ordered pair. Uh, an ordered pair when we're in physics, and y is uh, representing a distance, and x is representing a distance, right? If we're graphing distances on both, so this might be like 3 meters or 3 centimeters or 3 inches or whatever, then the position is just that ordered pair. Now, um, we don't necessarily need to uh, have position be represented as an ordered pair. We could also say, let's put in an observer, right? So we'll draw you, and you're smiling because you're happy to be learning about physics. And you're looking over, and you see, I don't know, let's just draw like some kind. Well, we'll draw a really, really poorly done, I don't know, cat or something. You see a cat. I'll work on my drawings. And you want to know, what is the cat's position? What is this cat's position? Well, you don't really have a number line, and you don't have an x and y graph. So an ordered pair, well, we could put this on a graph if we want to, but it might not be that useful for you. So, you are your own reference point in general, right? You observe the world from where you're standing at that moment, and you look and you see the cat, and you're really good at telling distances, and you're like, oh, this cat is, 3 meters away. And, this cat, because you're looking at it in front of you, you would say, oh, that's 3 meters away in front of me. 3 meters in front of me. And so then this is the cat's position relative to you, right? 3 meters in front of you. If I was standing over here, and I was kind of, maybe facing this way, I might disagree with you because, I'm facing this way, but the cat to me is, only it's 2 meters behind me. Okay, so the cat hasn't moved, right? Its position has changed though, even though the cat hasn't moved, because the cat's position, right, has got to be relative to a reference point. Okay, so this little example kind of shows why setting a reference point is so important, and why in physics, uh, well, we can sometimes take it for granted that we always set it to 0, but there's a reason we do that. And so we don't get confusion like this, right? Where, if you were two physicists asking what's the cat's position, this could lead to a lot of confusion because you would both be convinced you're right. And the only way you could resolve it is by realizing our reference points aren't the same.